another episode of the Open Source Cafe. Today we're talking about network policies, and we have Uri here with us from Authorize. Uri, thanks a lot for joining us. And before we get started, can you maybe tell us a little bit more about yourself to the viewers?
Sure. So thanks, Kunal, and thanks for having me. Let's see. I've been in technology for many years. I'm actually a recovering particle physicist. So I had a previous career. But in the last 25 years or so, I've been doing technology full time. I've started a few startups. The last one was when I was CTO for a company called MuleSoft. Did a lot in the API space, the integration space, and then co-founded Otterize about a year and a half ago with Tomer and Uri, and we'll be talking about it today. But it's basically an open source project, and we also have a cloud offering as well.
Amazing. Well, really looking forward to speaking to you more about it and talking about developers. Ever since the DevOps thing and all these big terms are coming out, developers are spending a lot more time with things they don't need to, and they're just like, I just want to write code. Why am I working with this YAML file or these platforms or all these other things? And now this thing called platform engineering that is now out, which is sort of like trying to ease that. But anyway, we'll talk about network policies, and if we talk about let's say we get started with why should one care, and what are some of the challenges?
Yeah, maybe to strengthen the point that you just made about developers having to do things they don't really want to do. I mean, this goes back to the beginning of programming, right? You used to have to flip switches in order to program a large computer. Then we wrote tools so that you could actually just type stuff in, and then the computer would be able to read it and do something. And compilers basically avoided the need to deal with low-level languages and let you express things in higher levels. So we're always looking for how to be more and more efficient in this world called software. And then on top of that, we introduced more and more aspects, right? So you had to start worrying about persistence and about security and about 100 other things, which are not literally themselves the functional aspects of the software. So it makes sense that we're worrying about other aspects, but it also makes sense that we're trying to sort of automate them and put them somewhere else so that developers can really focus on direct value add. And now there is a whole practice called platform engineering. That's not just DevOps, not just a reactive way to respond to things, but really engineer the way that we get the most value out of developers. And that's really what Authorize is based on. So that's where we fit in. We give you a way to realize more security probably than you ever thought you could realize in a quick way, but with a lot less work than you're doing today, and even the more functional things. And that's what I'm excited to talk about today.
Couldn't agree more. And when we talk about policies, let's talk a bit about access control as well.
Yeah.
So can you maybe, before we move on to I asked the follow-up questions, can you share a little bit about why you should care about that? Especially as an organization, you have people joining, leaving, for example.
Right.
So
yeah. The challenge for an organization really is to say, look, on one hand, I want to embrace a lot of change. I want to embrace the latest and greatest technologies. I want to move to not just Kubernetes, but I want to use more and more cloud services, and I want to use maybe service meshes, and I want to use all of this great stuff. More specifically, I want my developers to be able to tell me, hey, we should be using this because we're going to get a lot of value out of it. So there's a natural proliferation of more and more technologies and more platforms that development teams either want to use or are forced to use because that's the right way to do things. So that's kind of one side of it. On the other hand, when you get proliferation, and in general, when you get sort of the kind of world we live in, you know that security is more and more important. Sometimes it's not so much that you want to get security, you just want to access RDS, or you just want to access something. And the only way to do that is in a secure way, right? You're going to RDS, it's a shared platform. By definition, you're going to at least authenticate. And in many cases, you're going to need to get authorization to go and use that platform, right? Can I get access to that table and so on? There'll be other times when you actually want to drive security itself. So you say, look, It's not okay for us to expose all of our information on Kafka to anybody who can reach Kafka. We actually want to say this information and this topic should only be exposed to these clients and so on. So sometimes it's driven by security. Sometimes it's driven by the simple need to get access. But as you need to get access in a secured way to more and more things, and there are more and more things, that's the proliferation of the platforms, there are two ways you can go. You can either become really good at all those ways and spend your development time learning and figuring out those mechanisms and doing it again and again. For every time you have a new developer in your team or every time you adopt a new platform, everybody has to learn that. Doesn't feel scalable. It isn't scalable. Or you can say, I've got a different approach that lets me do attach, connect securely, and I can do it sort of, to all the new developers without having to teach them something else. But it still checks the box in terms of it works with all the platforms and it's very secure. And so that's kind of the approach that we've taken.
And can you tell us a bit more about Authorize? Yeah.
So Otterize, first and foremost, is trying to advance a new way of thinking about doing secure access controls that inherently, just in its nature, solves the problem of the complexity, solves the problem of how do you get developers up to speed, solves the problem of how do I maintain these best practice security controls over time. And the way that we think that it should be done is going to sound very controversial, right? It's called intent-based access control, right? And intent-based means you simply ask the client of any service, of any resource, of any API, you ask the client, what is it that you need to call? You don't say to the server team, hey, go figure out who's calling you and make sure they do it securely. You ask the client team just, what is it that you want to call? And based on the collection of those things that need to call a server, you generate the server access controls automatically. So instead of looking at managing the server permissions by having the server team figure out who's calling them, you go to the client side and you say, hey, client team, what do you need to call? And we'll make it all happen for you automatically. So it's client-oriented, it's based on client intents, and it's called intent-based access control. And what Authorize is we provide open source tooling to let you realize that approach. We don't actually provide the access controls. You actually have the access controls. We configure your access controls for you based upon the client intents.
That's interesting, like a new term, we're learning about today. And when we talk about access control, so can you share maybe the differences between a service to a user or like a service to a service and how basically you can secure this?
Yes, yes, that's a really critical question because there are fundamental differences, even in just the lifestyle, between user to service and service to service, right? User to service is, there's, say, a developer or even an end user. And you have to figure out, like, what kind of access do I need to give them? Well, to what end? Like, why should they have access at all? And what do they need to do? And it's often pretty hard to figure that out. So for a developer, you want to say, well, they need access because they're triaging an issue, or they need access because they're building automation, or so on. And there's lots of cases, but there's not sort of a way to define exactly what access they need. So you basically manage controls and policies and so on. Similarly, with an end user, you have to figure out where does that plug into your application's functionality, what should a user be able to do, and so on. In the case of service-to-service access, it's usually very repeatable. The service will do the same kind of thing over and over. The client service will do the same kind of thing over and over again. So you can imagine that there's a different approach you can take to it. And then the mechanisms that are used to enforce that access also tend to be different. You can demand of a service to a client service to present certificates, right? Good luck demanding individual end users to present certificates. That's too much of a load. But it's okay to do that with a client service, or they can refresh their tokens. So you can do things in the service-to-service world that you wouldn't do in the user-to-service world, and vice versa. And so we focused ourselves on the service-to-service world. There's actually a lot more access service-to-service than there is user-to-service. If you just think about it, there's a lot more services talking to each other than there are users talking to services. And also, that's also a fertile ground for breaches, right? So in a large, complicated deployment where there's lots of services talking to each other, if you simply assume that every service that can reach another service should be able to talk to that service, you're just setting yourself up for some kind of attack. And we've seen more and more attacks like that recently, and that's kind of why the push to zero trust. So again, you want to treat differently service to service versus user to service.
I have one follow-up question around network policy since we're talking about that. So, can you trust them?
Well, it's a good question because you have to get to what do you mean by trust. So, you can talk about, does Kubernetes and the CNI kind of interface and the actual CNI you use, say Calico, do those work correctly? And for our cases, we're going to assume that the answer is yes. So I'm not going to focus on, can you trust the fundamental pieces of the software that implement network policies? I think the biggest question you have to ask about network policies is, are they giving the correct access? And that's where real trust issues arise, right? Can I trust that if I implement network policies on everything and I make sure that, only things that have a specific network policy are allowed to talk to each other, then I'm not going to break the functionality of my application? That's perhaps one of the biggest sources of mistrust because network policies are hard. And think about what you're doing. You're basically saying, I'm going to define every connection, right? Point-to-point connection between any two services that can talk to each other. And I bet it's going to be right. And I bet it'll stay the same. And as we go through release after release, and as the code evolves, we're always going to keep that map of what is supposed to connect to what correct. That's a lot to swallow. And intent-based access control really solves that problem in one fell swoop.
Amazing. And when we talk about intent-based or when we talk about Authorize, what can I compare Authorize with? Maybe can you compare it to service meshes? Or how is it different than service meshes?
You can certainly compare the outcome or the things you're trying to get to service meshes. You can also compare the outcome to network policies. You can compare it to any kind of set of access control that realize let's call it zero trust. Whether or not you're kind of in the camp that you like the word zero trust or not, I need some way to say that only the appropriate services can call each other in a secure way. Let's call that zero trust for the sake of our discussion. So can you compare it? Well, anything that realizes zero trust, you can compare Authorize to. The difference is that we use those mechanisms in order to make zero trust happen. So for example, let's say you have Istio. You know that you can completely control the communication between pods, right? Because you've got a sidecar, say Envoy, running in each one of these pods. And that Envoy can basically have rules to say only this can talk to that. So great. Is the service mesh there for the answer? Well, no, because the question is who should talk to who? How do you configure those envoys? That's the hard part. And intent-based access control only solves that. It captures who should talk to whom. Authorize then turns that into an Istio configuration. So we will configure Istio automatically to allow all of the declared calls and to block anything that's not been declared. That's where Authorize comes in. It's a configuration for Istio. It's a configuration for network policies. And it automatically maintains itself. So as you change what you declare, your code today calls server X, and tomorrow it's going to call server Y. We will update the network policies. We will update the Envoy configuration such that your client can only call Y, can no longer call X. So the end of dangling permissions, the end of a more and more permissive network as things evolve, it's always tailor-made that you only get the access to the stuff you actually need and no other access.
When we're thinking about intent-based access control, how widely adopted is that, and where are we headed like right now? If we talk about like, are there any like maybe shortcomings that are so basically what's keeping folks from widely adopting it?
Yeah.
Right. And if you talk about like, so the client side, making like showing the intent, can you control that, like in terms of if you talk about like where do you store the metadata and the security stuff?
Sure.
So what would lead it to be like widely adopted across organizations across the globe?
Yeah. So, I mean, why it's not widely adopted is because really we've only started talking about this now, which is interesting. I've had a lot of people ask me, so this approach just makes a ton of sense. Why hasn't it happened before? I think there's 1,000 things why things that may seem obvious in retrospect don't happen until a certain moment when they do happen. So it's too early to tell whether this gets widely adopted, but we think it's just a very sensible approach. And we're following a pattern, right? I still remember when Kubernetes first came out, and it was an intents-based system from day one. You say, I intend to deploy the following capabilities, the following services, and I write a deployment manifest to say, this is what I intend to happen. And then Kubernetes will translate it into, I want the following pods. The pods have the following container specs in them. Containers can go out and actually spin up that software, and then Kubernetes, will do health checks and so on. But all that you had to do is to declare your intention to deploy something. So that intent-based approach, tell me at the high level what you intend to do, and I'll take care of it. That, I think, has been really, really well accepted now. And we're just applying exactly that same approach to access control. So I think, if we follow in those footsteps, it will become a very broad accepted capability. But you ask a good question, like, why is this a reasonable capability? Why is it reasonable just because a client declares that it needs to call something, that it gets access to that service? And that's where I think the other interesting aspect of IBAC comes in. Think about the existing code approval process. When I write a client to some server, I have a bunch of code that calls that server. Somebody should be approving that code, right? There should be, an organization should have some approval process to say, it's a reasonable thing for you to go and implement that functionality. All that IBAC says is explicitly approve as part of that the intent to call that process. Don't just look inside the code for how that server is called. Also realize you are calling that server, you are making that call, you are accessing that data. Is that okay? So the intents are supposed to live along with the code that actually implements them. And as part of approving that code, you should approve those intents or deny those intents. And we are simply going to piggyback on top of that. So if you want to have more approval, hey, it's not okay for this client to access that data without further review, then go ahead and integrate that into the approval of that code. That's the approval for the intent as well. Now, over time, we will be building extra controls, operational controls, to allow you to see, okay, these are the requests that are being approved, and maybe let you automate things like, well, I would like to approve them automatically, say, in a dev environment, but I don't want to approve them automatically in production environment until they undergo X and Y review. So there will be controls and checks and balances, but those should happen as far left as possible. Those should happen at the time when you are changing your service or implementing a new service and saying, I want to access the following topic in Kafka. And somebody should be saying at that point, is that appropriate? Don't wait until the thing gets into production and then you figure out, wait, that wasn't appropriate. Do it at design time. That's what IntentBased is supposed to do. It's supposed to be at the design time of the client. Why the client? Look, when you roll out Kafka, you have no idea how it's going to be used, nor should you, right? That's way too early. The time that you should be making these decisions is when you start to consume that data. And that's why IntentBased is really client-oriented.
Yeah, and we talk about like people monitoring their performances and the networking and all these other things. I think in the maybe future, if we look at over time, maybe in the longer run, they no longer care, whether something is happening at like if we talk about networking, like at layer 1 or layer 2 or layer 7 or whatever, they just want it to happen. And if we talk about networking, like specifically if I talk about, let's say starting with or onboarding with intent-based access control, with the way people are doing things currently, how would you encourage them to, let's say, try it out or get onboarded or just at least get their foot in the door?
Yeah. So let's look at specifically networking. Maybe you mean specifically network policies, I would guess, rather than something lower level down in the networking stack. Does that make sense?
Yeah.
Yeah. So in the sense of network policies, I think probably, the audience splits into two camps. Those who are trying to embrace or maybe have embraced network policies to some extent, and those who look at it as a, there be dragons kind of thing. My God, I have to now start putting labels everywhere and figure out IP addresses and figure out who's supposed to talk to whom. Maybe I'm okay to do that on the ingress level, but maybe not really for anything else. But in either case, network policies are really built into Kubernetes. Like that is a capability, at least, or an API that is built into Kubernetes. So it's right there at your fingertips and very easy to try it out. Adding a CNI, if you don't already have one, is very straightforward. A very popular one is Calico, and a lot of the managed Kubernetes already offer a built-in CNI that implements network policy. So the tools are already there, right? To try it out, we have very simple tutorials. You can try it out in your own cluster. Just go read the docs on Authorize OSS, and you can very quickly start to play in a little cluster and say, okay, what would it look like to really manage network policies? That's where a lot of the There Be Dragons comes out. But what does it look like to manage network policies through just intents, and play with that? And if you've realized that in the end, it's really simple. It's just you have to, maybe we can show the YAML. If you look at what you actually have to do to manage network policies with IntentBased, you do something like this, right? So if we look here from the top, you basically say, hey, I'm the checkout service developer. I'm not going to worry about network policies, but I'm the checkout service developer. And I'm telling you, looking at just the top of this, I'm going to call the cart service and I'm going to call the shipping service. So, hey, I need to access those two things. When you go ahead and kubectl apply this, and you've got Authorize OSS in your cluster, network policies will automatically form between the checkout service and the cart service, between the checkout service and the shipping service. You automatically get network policies between them. To do that, we also have to label the checkout service and the cart service and the shipping service, because that's how network policies bind themselves to things. We'll do all that work for you. You don't have to care about it. If you care about network policies, you can see what we did. Obviously, you can just query with, canines, maybe you can just query what the network policy is. But as far as you're concerned, checkout service now has access to cart service and shipping service. And by the way, cart service and shipping service are now protected. So if you breach another service, you can't get at cart service and shipping service unless you are the checkout service. That's interesting. I both protected a couple of my services and guaranteed the access to the checkout service client. You might want to say after that, all right, so let's see, who else should access the cart service? And check that client out, create another manifest for it saying, okay, who do you want to act? And soon enough, what you have is for all your services, they all declare who they need to call. And the network is totally knocked down to only those declared intents. And so you see that all you have to do is to declare who you want to call, and you automatically get zero trust kind of out of the box and never have to think about actual network policies. You just know in the background they're protecting everything.
Amazing. Well, thanks a lot for sharing, Uri, and all the resources that were mentioned. I'll leave those in the description below so you can check it out. This is one of many, content pieces that we are doing. I have so many things in plan to educate folks around intents, and I really appreciate you giving the time, Uri. Thanks a lot. I definitely learned a lot and gives me a lot to, research and explore and learn more about. For everyone else, you can check out the links in the description below, and we'll see you in the next one. Thanks for watching. Have a great day. Bye.
Thank you so much.